Hello and welcome in this presentation why and how build your own web server in C#. I'm Luca and I will present you the last project I worked on it, how I did and why I did. Before starting talking about the project, maybe some introduction about my developer journey that will explain you why I starting to be interested about building my own web server. I think that my journey will feel familiar to many of you because I first start to explore IT very broadly. I learn what is computer, how server work, how internet function, what is a website, all this kind of stuff. Of course, after that, I would create my own website. So I starting to use a CMS to build one. Then I began to learn code, HTML, CSS, JavaScript, PHP, a lot of other language. And naturally, the next step for me was to use my coding skill to create my own website, but this time from scratch without any CMS. But when we have our own website that presents you safe, we need to think about, okay, what else we can do, what else we can build. At this moment, you have different possibilities. And I think is where our path start probably to go in different direction. Most of us, and including myself, the next step is that to build more application. So you have the classic to-do list project, you have a booking system, and so on. But it's not the only path. Some prefer focus on infrastructure, and so will handle server and services themselves. But in fact, we could continue to go deeper, like why stop here building a website? Why not trying to create your own services and like your own web server? The main reason is probably that because we are software engineer, and as software engineer, we are focused usually on building application, developing new feature, implementing business logic, but not really about system. In my career, I made a transition from software engineer to site reliability engineer. And it's at this moment that system become truly important to me because like my focus shift towards service, how to monitor them, how to automate action to the service. And it's at this moment that it hit me. Why I do not build my own web server, one that will solve maybe my biggest frustration with existing web server. Before the first thing, okay, is to understand why we want to build a web server and not something else. Okay, it's very challenging to build a system, and you have many things to consider before starting. First is a great opportunity, okay, to learn about the fundamental service. It will help you to better understand how the current system works and why they are designed this way and not another. Like any project, of course, is a great way to showcase your software engineering skill, especially if you are back-end engineer, where it could be more difficult than when you are front-end and can create a website. But why a web server? Why not like a database, for example? The reason is simple is because a web server is relatively simple if you compare to database. But even if it's simple, you have a variety of complex problems that you need to solve. So before the how, let's talk about the what, even if I think we all know what is a web server, but it's still important to define what we want to build before jumping on the code. A web server can be described through a few key functionality and non-functional. First, it's a service running on the host. It's listening on a port, usually the 80. It can manage HTTP requests and it will generate HTTP response. So that is for the functionality. The non-functionality will be a web server is secure with authentication, is reliable, that means it will not crash when he will have heavy usage, its performance and have a good scalability, and is not necessary too, but I had it for my web server. It needs to be easy to operate, especially for administrator or SRE. The first challenge is even before you start to build it. The first challenge is about the platform. Most of web servers today run on Linux, so if you are building one today, you need to work on that platform. But at the same time, I personally use Windows, and I remember that my first web server that I installed, that was Apache with the WAMP stack, was on Windows, and so I want that my web server be available also for people that didn't migrate yet on Linux. So that is the first challenge. Fortunately, today, at .NET Core, you can write your code in C# and run it both on Linux and Windows. It was not the case before, so I'm really happy today to be able to do that in C# is a huge progress for us. Of course, there is still some platform-specific consideration, okay, like the path, the metric, or everything about the scripting, but we can handle this challenge with the right architecture and the proper abstraction. So now let's take a look at the code. Building a server and connecting to it is in fact pretty simple. What we call a server is essentially just a TCP defined by an address and a port. And that's it. You can start it and it will begin to listen for incoming connection. It's so simple that someone recently tweeted, wait, a web server is basically an infinity loop. And while, of course, the real answer is more complex, it's not entirely wrong. We can define it like an infinite loop and that's all. The step 2, okay, I connect to my server, is pretty cool, but to really be a web server, you need to do what a web server do. That means respond with an HTTP response. Otherwise, it's not a web server, it can be another kind of server. HTTP request and response are actually quite simple to understand. They consist in 3 parts: the status line, the header, and the body. Each part will be separated by an empty line, so it's like really easy to parse or even to read. To test that, we can create a basic response and send it back to every connection. And with a simple GET request, we can see here the GET request to my localhost port 80. We can see that my server responds with hello world, just as expected, and the HTTP response is understood by the program that called it. Of course, we need to add more logic to our service. That means we need to pass the HTTP request that, again, is like the response very simple in 3 parts separated by a blank line. Okay, with this parsing and especially the HTTP request line, we can start to introduce some logic to handle different requests instead of always returning hello world. Okay, challenge number 2, handling connection. Our server receives connection and we need to manage them properly. So let's set the following requirement for our connection module. The component that handles the connection should be modular to make it easy to integrate, remove, or change in the future. When we receive a connection, we need to decide if we will accept or reject the connection. The entire life cycle of the connection must also be managed. That means we must accept the connection, but we must also ensure it gets closed properly. And of course, the request should be shared, and an HTTP response must be sent back because, after all, we are building a web server. Our service, that is the main program, will have in fact different modules. And the first one, where we call it the web module. This module will include functions like start, run, stop, and with the run function, we will handle the connection. The previous code is now moved in the run function of the module, and we can see that when a connection arrives, we accept the socket, and we call the accept connection async to manage it. A connection is the first challenge because they consume a resource to your server. This means we need to set a limit of the number of connections we can accept at the same time. So we will implement two limits. The first one is the number of connections we will serve. That means the connection arrives, we accept the connection, and we will do regarding the path in the request what the client asks to our server. When this limit is reached, that means we are starting to serve too many clients in the same time, we will start to reject the connection, but still with a limit, a second threshold for the connections that we can serve, but we can still respond with a good HTTP response. And finally, if we are really overwhelmed, well, we will simply close all new connections without any response. It's a little brutal for the client, but is needed for the server because it really cannot just answer. We will start with the connection that we reject nicely because it's this shorter path So when we receive a connection that we cannot serve, we will return an HTTP response, and in this case, we will use the status code 500. This way, we manage the connection quickly, and so we use a minimal resources, but the client still know what happened on this side. When we decide to accept the request, the process becomes a little more complex. So first, we need to know that our web module have a specific attribute called pipeline. This pipeline is a reference to a function, and after passing the request and before sending back the HTTP response, we must pass through the pipeline. When a connection arrives, we have many actions to perform on the request, and also the response, in fact. For example, we need to log that a request arrived. We need to check for the authorization or the authentication if it asks for resources that is protected. We need, of course, to route the request in the right resources or endpoint, and we can do like many other stuff in this request or response. Each action in a web server is handled by what we call a middleware, and the pipeline is the chain of execution of this middleware. Here, a visual example of the pipeline and all the middleware that are composed. Each middleware receives as parameter what we call a HTTP context. It will contain all information about the current request and the response, everything. When the first middleware finishes what it needs to do with the HTTP context, it will call the next middleware. Each middleware is called in sequence. To configure the pipeline, we can look the init function of the server, not of the module, of the server. So where we create the module. We will first set a first pipeline that is a web. We will create all the necessary middleware and link them together. Okay, so we start with the terminal middleware because we start by the last one. Then we create the routing middleware that will be connected to the terminal middleware, the directory middleware that will be connected to the routing middleware we just created before. Same thing for the authentication middleware and the logger middleware that is the first one. Then the web module gets the reference only to the first middleware, in this case, the logger middleware. We can have a look how middleware works. So here is a simplified version of the router middleware. We will check the HTTP context for the request and what verb is used. If it's a GET request, we will handle it. Otherwise, we will not manage in our case, so we will just return a HTTP response with the code 404. After, we call the next middleware in the pipeline with await next and passing the context in parameter. Since we are in the middleware, let's take a moment also to see how we create an HTTP response for a resource that exists. Let's imagine that the request is for the file index.html. The router middleware will look for this file, is in the main directory, so the www directory for your web server, and we find it, it will generate an HTTP response with all the necessary metadata. Metadata is like what is the meme type of the resource that you return, so based on the file extension, is the content length of the body and of course the content of the file in the body, and the HTTP code that is 200 because we find the resources. If it doesn't find the file, in this case we will again generate a 400 for HTTP response instead of content of the file. However, even if the response is ready now, we will not send it yet. We simply add it to the HTTP context because we don't know if other middleware need to perform some action on this response before sending back. Pipeline and middleware are very common in web services and in this architecture. It had many advantages such as modularity and reliability. We will explore that just later. It's really easy to extend, so because you can add any middleware to the pipeline without much effort at any place. It's easy to maintain because each middleware has only one responsibility, so it's easy to maintain and also to test. It can also help with the security because the request must pass to all the middleware. It didn't have choice. So in our case, for example, we include authentication middleware. It's like the second middleware that we called. Like that, we ensure that each request goes through it and we know if the request is authenticated or not. You can also put a rate limiting if you want a specific middleware for that. Again, you can add any security layer that you want. Okay, let's look at another challenge number 3. How to administrate and operate a modern web server. So by administrate and operate, like how I do to change the configuration, if I want to restart the service or stop it, if I want to get the log of my service, all this action. For most web server, it's required to connect directly to the server, so to the host, and to perform some operation to get this information. But okay, we are in 2025 now, and we don't usually manage just one web server. We often manage 1,000. So I want to be able to do everything remotely. And when I say remotely, I didn't say connecting remotely to the host. I mean to an HTTP endpoint for my application. I want to operate my web server to HTTP endpoint. And that's great because like we're building a web server, so we already have everything in the app now. We just need to add some endpoint for administration. So we could do that, but another requirement we want also is to have an administration services that is independent of our main module, the web module, to be able to have better control on the both. In fact, I want a transition from my architecture where I have one web module with the TCP listening on the port 8080. I want pass to two modules, one web module and one admin module, listening one on the port 8080 and on the other on the port 4040. Again, the port is just an example. So each module will listen on his own port and be completely independent of the other. That means we can run one without run the other, it will be okay. So don't worry, we will reuse what we already done in the first web module. We will just need to make few adjustments. Let's talk about the pipeline. There will be, of course, very similar, the pipeline and the admin pipeline. But we will replace the routing middleware that is used to get the resource on the server with the admin middleware to handle the operational task that we want. So still in the init function of the server, we will create our new pipeline. Okay, we can reuse most of the middleware we already had, so the terminal middleware, for example, or the logger even. But this time we will have our admin module, okay, that will start with the admin logger middleware. And this admin logger middleware will be connect, of course, to the hot middleware that it didn't change. And the hot middleware will be connect to the directory middleware. And the directory middleware will not be connected to the water middleware this time, but to the admin middleware. We change the middleware. So we have a connection manager that is a module. So the connection manager admin this time inside of web. So we have two modules, two connection manager now with two different pipelines. Let's take a look on the admin middleware. It's very similar to the water middleware, a little more long maybe, because this time we will not look for file, okay, or for resource. We will look for endpoint. So we have the main endpoint like status, reload, restart, logs, and when we hit this endpoint, we will execute the corresponding function of our web server and return the result of the function on the HTTP response. For the status, for example, we have the variable status in our server, so we will get this value, put it in the body of an HTTP response and return it. Same thing for the reload. We will execute the reload function that go read a configuration file and return that the configuration is reloaded when it's done. Since authentication is very crucial for the admin section, even if it was implemented before, let's have a look now how we handle this part. Here we've implemented the simplest authentication method, because remember, it's always good to start simple before going in complex area. So we use basic authentication. Okay, it's not the most secure option, but it serves our purpose right now. Okay, it protects the endpoint with an authentication. What we ask, we didn't ask to use the more secure one, but of course in production you could not use that. So to make this work, what we do, we have an HTTP request, and in this HTTP request, we have in the header, if we're sending an authentication, we will have the header, and from this header, we can get the username and the password. We can then check if it matches with the username and the password we have in an access file in the server. If yes, the user is authenticated. If no, is not. We will so just add in the context, in the HTTP context, that the user get authenticate correctly for the directory he asked at least, and like that in the next middleware, okay, we have this information, we don't need to check ourselves. One of the current challenges with administration endpoint introduce a sub-problem. How do we provide enough endpoint to ensure that the administrator can perform all necessary tasks without accessing directly to the server? Okay, so sure, like we have some endpoint for log, for stopping, restarting the server. But what if the admin, I don't know, like won't check some permission or handle other custom scenario, like we do with Bash, for example. We cannot anticipate every possible scenario. So we need to find a way to offer flexibility to the administrator, but still to HTTP endpoint. That's why we have another endpoint called script. This endpoint can do many stuff. Either it can list all the script present on the machine. So if you just hit the endpoint script, is what it will do. There is a specific folder in the server, and all the scripts that are in this server will be displayed. And if you use this endpoint with what we call a param, a query parameter, well, we will execute the script based on his name, and his name is what is the value passed in the query parameter. The administrator now will be able to upload any script they want, and later execute it via an HTTP request, with of course the result of the script that will be returned as. Since the script depends on the platform, we naturally need a different implementation for both Linux and Windows, but that is a really small issue, like I said at the beginning. It's just abstraction and different implementation depending on the platform. Okay, now we solve the issue with the admin endpoint. Let's talk about the challenge number 4, logging and effective logging. Logging is crucial for administrator or SRE. And a good logging is even more important. Of course, our application need to handle it very well. Since we have different and independent modules, logger of this module, so the logging system must reflect also that. For me, a good log should include at least the following information: the date, the module, the thread ID, the level, and of course the error message. Okay, to fully understand the issue we have with the login, we need to keep in mind that the two modules, web and admin, are two instances of the same class. And this instance can call the same function, the logger middleware, and the logger middleware, when he logs his information, must be able to distinguish between which module is calling it when he's writing the log. Since both modules are essentially the same, we need a way to identify which module is interacting with the logger at any given time. This means that the logging system should be capable of tracking the context where it's from. If it's from the web module, if it's from the admin module, to answering that the correct information is a log. To solve this, we must first understand the concept of execution context. Each part of the code runs in its own context. When the server runs, we are in the main function, we are in the main execution context of the program. When a new task is created, it forms a child execution context. And something important to know, of course, is that when we run the server, so here is a function run async, not of the module, but of the server itself. The server will start its module in a new task. When we enter in a child execution context, it inherits from the parent. In most of the case, we won't care about this information, but it's actually one of the solutions we can implement for our module. We can create a static class named execution context, which contains a static variable of type async local. In our case, it's a local async, but it could be any async local type. This variable will have a getter and setter, allowing us to modify the value and to get it. What is great about this approach is that because the class is static, it will be accessible everywhere. But important, the value is held will be unique to each execution context because of the async local. Let's take a look how it works in practice in the module. So let's come back to the start method of one of the modules. Either if it's the web or the admin module, anyway, is the same start method that is called, so it's okay. At this point, we will set a new logger, and we will save this new logger that have the module name directly in this constructor. We will save it in the x.logger variable. From here, this logger value will be specific to the execution context in which it was set. All child execution contexts, such as task or asynchronous operation, with that context will inherit this logger value. This answers that each execution context has its own logger instance and can log with the appropriate module-specific information without interfering with other contexts. What that means is that when we are in our web module or admin module, the logger used is always tied to the specific execution context. This happened because what we set up with the async UKI variable in the execution context class. We ensure that each execution context has its own logger. So when you log a message using execution context.logger, it will always use the logger that was defined for the current module execution context, whether you are in the web module or admin module. This is true no matter where you are in the code. As long as you are with the context of that module, even if you call a function or use a class that are part of another class outside of a module, they will inherit the logger from the current execution context. This way, your logs stay consistent and specific to the module from which they are generated. And so it makes it easier to trace or to debug. So when you call any kind of middleware, like the logger middleware, and you do execution context.logger.loginfo, we know which logger it is because we inherit from the execution context of the module. So there is, of course, a lot of other trials that I didn't mention here. You can take this talk like an introduction of how the problem you will need to solve when you want to start to build your own services. After, depending on what interests you the most, you could consider to investigate performance topics, so like with the caching or the multiplex request, maybe more a security feature like the HTTPS, because for the moment everything was in HTTP. That's why basic authentication was really not secure in our case. Also maybe other authentication method, or if you are more interested about what also do SRE, think about the monitoring of your application, so how you can generate metric, what new endpoint you can provide to get this metric, etc. There is one bonus trial to finish this presentation. I would actually mention it, so because is what name you will give to your web server. Of course, you create a web server, you need to give a name. It's the most interesting part, I think. It's a really interesting exercise because it unlocks your creativity, and myself, I would be really pleased to have some idea you have in mind if you need to create your own web server, what name you will give it. The mine, because I built mine, took inspiration of the most known, that is Apache, and that I really like Panda. I decided to name it PandaPache. So if you want to explore the code of a web server in C#, you can easily find it on GitHub under the name PandaPache3. Thank you for your attention and your time. I hope I gave you interest on this topic, and enjoy the rest of the conference. Thank you.